Hi everybody, this is day 4 of our circles notes on Thales' theorem and cyclic quadrilaterals. So Thales' theorem is really just an expansion upon something you guys already know about, and that's inscribed angles. We know that if we have an inscribed angle, which maybe looks something like this, where the vertex is on the edge of the circle, okay? That means that if its intercepted arc is 60 degrees, the angle itself will be 30. It's half of the intercepted arc. So if I look at this depiction over here, I'm recognizing that FH, because it's going through the center of the circle, is the diameter. And if that's the diameter, then that means this intercepted arc you guys are seeing, I'll highlight that in green there, is 180 degrees. So if you focus on the angle created by the inscribed angle, FGH, that means it must be 90. So Thales' theorem is really just a specific case of inscribed angles. So an angle inscribed in a semicircle, so half of the circle, which you guys are seeing right here, this is half of the circle that it's inscribed in, is always going to be a right angle, okay? So, like I said, for example, the measure of FJH, and again, we're saying measure, not length. Measure is in terms of degrees. The measure of that intercepted arc was 180 degrees, so angle G must be half of 180, which is 90, which is a right angle. So coming on down to our first example here, if I were to give you a picture like this, first thing you should recognize is that angle G must be a right angle because that's an inscribed angle in a semicircle. Okay, and again, that's because this degree measure or the measure of this arc over here is 180. So measure of angle G is simply 90 degrees. Now, with that being said, if I want to find the value of x in this picture, then I know the sum of the interior angles of a triangle is 180. So I could do 7x plus 2 plus 17x minus 8 plus 90 equals 180. Or if you really want, some of you guys may jump to this step right away. If 90 degrees is accounted for right here, then it must be true that these two angles sum to 90 because 90 and 90 makes 180. So whatever you want to do, it doesn't really matter. So from there, I'm just going to combine my like terms. So I've got 7x and 17x, which gives me 24x. And then I've got negative 6, which I can add over, which gives me 96. So when I divide by 24, I would get x to be equaling 4. What is the measure of angle F? Well, I know F is 7x plus 2. So 7 times 4 plus 2 is 28 plus 2, which is 30. Measure of arc GH. So GH, that little guy right there. Well, GH, if I think about what this angle is, angle F, I just said that angle was 30 degrees. So if that's 30 degrees, and that's an inscribed angle, because again, the vertex of it is on the edge of the circle, then that means that the intercepted arc must be double it. So that must be 60 degrees. So again, 2 times 30 is 60 degrees. If I want the measure of arc FG, and again, I know this is the minor arc. Excuse the noise there real quick. It's my email. So if that's the arc FG, I know that's the minor arc because otherwise they would have said FHG going around the other way. Well, that arc is intercepted by this angle. Okay, so here's what I know. I know this angle at G is 90 degrees. I know this angle at F is 30 degrees. Which means that the remaining angle H must be 60 degrees, because then it would be 30, 60, 90. That sums to 180 degrees. So now, if this is 60, if you double 60, that gives you 120 degrees. So that's one way of thinking about this. Another way of thinking about this is if you know that this is a semicircle, which we do, because I have a diameter drawn, well, we previously found that this arc right here was going to be 60 degrees. So 180 minus 60 is 120. So again, there's multiple ways to think about that. I used inscribed angles. The second way I used the fact that I knew that there was a semicircle. Okay, those are your answers. All right, so coming on down. In the figure below, AB is a diameter of the circle with a radius of 17 miles. I don't know why we went with miles on this one, but sure. So I'll just label both of those radii as 17. If BC is 30, what is the measure of AC? Again, since I know this is a semicircle that the angle is inscribed in, then it must be true that angle C is a right angle. 17 plus 17 is 34. So then what I can do is the Pythagorean theorem. So x squared plus 30 squared equals 34 squared. And again, that's because I know the hypotenuse is 34. That's the one opposite the right angle. So x squared plus 900 equals 1156. If I subtract 100, that gives me 256. And the square root of 256 is 16. So that means AC is 16. Technically miles if we want to go crazy here, which again, I don't know why we picked something so large, but sure, why not? So 16 is the answer. Okay, so that's Thales' theorem. The next and last thing we'll talk about in this video is something called cyclic quadrilaterals. So by definition, a cyclic quadrilateral is inscribed in a circle, and then its opposite angles are supplementary. So again, inscribed means that each of its vertices are on the edges, or on the edge of the circle. Opposite angles being supplementary means we know they sum to 180 degrees. So if I were to color code this maybe, I know L plus N would have to be 180, and K plus M would have to be 180. So I'm just going to write this over here. So angle L plus angle N equals 180 degrees. Angle K plus angle M equals 180. Okay, so coming on down. Quadrilateral WXYZ is inscribed in circle V. Find the measure of angle X and the measure of angle Y. Okay, so using what I know about cyclic quads, I know the opposite angles are supplementary. So X plus 60 equals 180. So angle X must then be 120 degrees. Then lastly, angle Y plus 95 equals 180. So angle Y must be 85 degrees, and it's as simple as that. Okay, now this next one's a little bit more challenging because I'm going to have to draw a picture for it. So quadrilateral PQRS is inscribed in circle O. Okay, so that means O is the center of your circle. Okay, so there's O. Well, it doesn't matter how you draw your quadrilateral, just so long as you know that each of these are inscribed on the edge. Actually, I kind of don't like how that looks like a square. I'm going to do a little bit differently. Okay, so maybe it looks something like that. Again, not drawn to scale, just for help. And then maybe I'll call this P, Q, R, S. Now they're giving you a ratio. The measure of angle P to angle R is 2 to 3. So that means I'm going to call angle P 2x, and angle R, 3x. Okay, x is that relationship between those. So whatever x is, you double it, you get angle P, you triple it, you get angle R. So if I want to find the measure of angle P, well, again, I know these are opposite angles in a cyclic quad, so I can sum them to 180. So 2x plus 3x equals 180. So I'm getting x to be 36 degrees. Now angle P is the 2x, so 2 times 36 is 72 degrees. Now I want the measure of angle SRQ. So, SRQ. SRQ. Now, if you take those endpoints here of that arc, so S and Q, and you trace them back to the angle that intercepts that arc, you will see an inscribed angle. And you will see 72 is the inscribed angle. So based on what we know about inscribed angles, if I double it, that'll give me the measure of the arc, which would be 144 degrees. Okay, now it wants the measure of SPQ. So SPQ, again, I'm going to take the endpoints of this, trace it back, and there you see your inscribed angle of the 3x. Now, there's actually a couple ways of doing this problem, but I'll do it this way first. Well, if I know that x is 36, then I know that 3 times 36 is 108. Just like last time, I can double that angle. So 2 times 108 is 216. And that would be the measure of that arc. So 216 degrees. Now, I said there were two ways. You know that the number of degrees in a circle and all of its arcs put together is 360 degrees. So technically, if I know this arc in green right here is 144, I could also do 360 minus 144. So 360 minus 144, and that would still give me 216 as well. So again, two ways to think about that part of that problem. Now lastly, what is the measure of angle R? Well, I guess assuming I did it the second way for C, I would then just half it, and that gives me 108. Or, as you can see, I had already previously found it via a different way. So, whatever you want to do there. Those are your solutions. Okay, so now in number 5, I'll admit there's something we forgot to mention here. It really should tell you that this is the diagram of circle A, so that way you understand that A is the center. And that is important for how we answer these questions, because sometimes you will have a point in there that isn't necessarily the center. So, our bad, you should have said that. All right, so find each of the following in the diagram. First thing it wants me to find is the measure of arc BDC. Now, if I take endpoints B and C and trace it back, you will find a central angle. And as we know with central angles, they are equal to the arc at which they intercept. So I know that arc BDC would be 120 degrees. Now angle E, which is up here, I'll highlight this in blue, that's an inscribed angle, which intercepts the same arc. So that means if I do half of 120, which gives me 60, that would be the measure of angle E. Now lastly, we want to find the measure of angle Y. Now, or I mean angle D, I guess technically you could look at it that way. Whatever we want to find Y here. How many Y degrees is that? So if you look at this shape, which I'll briefly outline it in pink, which is going to kind of bleed together with all the colors, that's a cyclic quadrilateral because all the vertices are on the edge of the circle. So with that being said, I know that these two angles are opposite, and therefore they must be supplementary. So I can do 60 plus y equals 180 degrees. So y must equal 120. Okay. In order to get more angles, we're going to construct an auxiliary line. So remember, auxiliary lines just mean an extra line. So we're going to draw in EA. Now, something I want you to notice here, guys, when we draw in that extra angle, that extra line, that's a radius, which means all of those are congruent. Okay, so that means this angle or this triangle right over here is isosceles, and this triangle over here is isosceles. All right, so it wants me to find the measure of angle EAB. Okay, so EAB is right over here. Now, here's what I know. If this angle right here is 24, then that means this angle over here must be 24. And that's because this is an isosceles triangle, and if two sides of a triangle are congruent, the angles opposite them are congruent. Now, in order to solve for measure of angle EAB, I could do 180 minus both of those. So 180, take away the two 24s, whoops, that should be a plus in there. Take away the two 24s would give me 132 degrees. So I'm going to label that right in here. Now, in order to find the measure of angle EAC, which is right over there, then what I'm going to do is recognize that this is a full rotation of a circle, which means it's 360 degrees. So I can do 132 plus 120. Okay, so 132 plus 120 gives me, 132 plus 120 gives me 252. And then I can do 360 minus 252, which leaves me with 108. 108 degrees. Now, in order to find the measure of angle X, again, now we're using the idea that we understand that if this is X, then this angle right up there must also be X, because, again, if two sides of a triangle are congruent, the angles opposite them are congruent. So, I can do X plus 108 equals 180 degrees. 180 minus 108 gives me 72. So 2x equals 72, which means x equals 36. So that means that this little guy, oops, I didn't mean to erase all of that. Oh, geez, hold on. There we go. We're back. That means this little angle right in here is 36 degrees, as is technically that one right up there. Okay, and that is question 5. Last example in our notes for today is solving for x and y. Again, I can tell this is center O. They have it labeled for me right here. So that one's an obvious way that they've labeled it. And this is a cyclic quad because each vertice is on the circle. So if I want to find the measure of angle y, let's say, first thing I'm recognizing is that y is opposite that 75, which means those must be supplementary. So I can do y plus 75 equals 180. So y must equal 105 degrees. I'm going to label that in here. Okay, so now what I want to do is somehow solve for x. Now, here's what I know about that. Well, actually, I'll do this. So I just solved for y, right? That's this angle. Now, watch how I trace this. That's the arc at which that inscribed angle intercepts. Now, as we know, I can double the angle, and that gives me the arc. So 210 degrees. Now, what we know is that x plus 120 must give me 210. So I can do x plus 120 equals 210. Subtract the 120, and x would equal 90 degrees. All right, and that's the end of our video. So that's the end of Thales' theorem, which again just says that if you have an angle inscribed in a semicircle, then that means the angle must be 90 degrees. So again, that's Thales' theorem. And then the last thing we just talked about were cyclic quads. So if you have a quadrilateral where the vertices are on the edge of the circle, then it must be true that the opposite angles sum to 180 degrees. All right, and that's the end.